Welcome students, welcome back for this class. During this class, we will study about another most important topic, that is stress. And then we will discuss during this class what the strain is. Basic concept of the stress is it is the external force acting on an object per unit cross-sectional area. Stress is a vector quantity that is proportional to the force causing deformation. If you look at, suppose I take any spring and I apply a force on this spring with the help of weight in downward direction. So due to this force, the length of the spring has increased. This increase in length, a direct force applied on any object, which results in increase in length, size of any object, a change in shape of the object, change in volume of the object, change in angle of the object. That direct force applied on the object is called stress. An increase in length, change in volume, decrease in volume, and decrease in angle due to stress is called strain basically. Direct force which we apply on any object to change its size, shape, or length, that is basically stress. If you take a empty juice can or empty milk can, you apply a force with the help of your foot. At the same time, the direct force which you are applying on the can, that is stress. But after application of the force, the volume or the shape of that can changes. That is basically strain. And this is the concept of strain. If you directly apply a force on this hanging mass hanging with the spring, and after application of this force, the length of this spring will increase. The force which you have applied to increase the length, that is called stress, and the increase in length is basically called strain. So let's come back. Stress is the external force acting on an object per unit cross-sectional area. Stress is a quantity that is proportional to the force causing the deformation. More is the stress, more will be the deformation. More will be the increase in length, more will be the force. So you apply a force with the help of this object on any other object. More you apply the force, more the type of deformation will be produced on the other surface. So formula to calculate stress is force per unit area. F for force and A for area. And it is symbol used for to stress is sigma. The unit of stress is Newton per meter square or Pascal. It has the same unit as the unit of the pressure. There is no difference in case of the unit. Now, this is a strain, but the strain is when stress acts on a body, it can change its length, volume, or a shape. I have given you example of empty juice can. When you apply with the help of foot, basically you have changed the shape. At the same time, there were some angle along the sides of that can. After the application of the force with the help of your foot is squeezes, means angles are changed, volume is changed. First is it was cube, and then it becomes a plane surface or a sheet. Before application of the force, the formula to calculate volume was different. Now the volume is changed. So it means after application of stress, the change may be in length, as I have discussed in case of a spring. The change may be in the case of volume, as I have discussed in case of empty juice can, and maybe in the form of shape, as I have discussed in case of empty milk pack. These are different examples where you apply some force on any object, and this your applied force is changing their shape, size, and length. So this force which you are applying to do so to produce such change, that is called stress, and these changes are basically called strain. Change in length is called per unit length is called strain. Volume change in volume per unit volume is called strain. change in shape per unit, per shape, original shape, that is basically strain. So these are different types of strains now. What about the change produced in size of an object due to stress is called strain. Now the tensile strain, if the stress produces change in length, then the ratio of change in length to the original length is called tensile strain. Change in length per unit length. That is basically called tensile strain. If you look at the unit of length is meter, this length is also in meter. So this meter is cancelled with this one. So no unit at the end. So if whenever there are two physical quantities, it is the ratio between two similar quantity, there will be no unit. So this is the reason stress has no unit, but strain have some unit. So here it is. The strain is equal to change in length, which I have already done, divided by original length. This is the change in length. This is the original length. Put the values of unit of length meter. Here it's meter. Meter will cancel with other meters. So there is no unit. So the symbol used to represent strain is epsilon. Epsilon. Strain has no units in its the ratio between two similar quantities, length to length. Strain is a measure of the degree of deformation. What types of the changes you are producing, what types of the changes you have produced after application of the force. Direct force which you have applied to do so to produce such changes, that is called stress. And after application of that stress, the types of the changes, either the length is increased, either the volume is changed, either the shape is changed, that is strain. And it is in case of tensile, it is the change in length per unit length. If you look at the units of these two quantity, units are same. There is a technique used in physics. If there are two physical quantities and the ratio between two physical quantities results in no unit. So it is found that the sufficiently small stress strain is proportional to stress. It is basically called a law which we will study, that is Hooke's law. This one is a spring, and if you apply a force on this spring in this direction, downward direction, you will see that less is the force, less will be the deformation produced. And apply stress within limit and release, it will come back. Again, you little bit increase the stress, release, it will come back. So within the limit for smart values and application of the stress and strain are proportional to each other. More you apply the force, more the stress, more the strain will be produced. But at a certain limit, beyond limit, if you apply the force on this spring, this spring will, after removal of the force or after removal of the stress, this spring will be unable to regain its original shape or size. So that is not within the limit. That will be beyond the limit. So within the limit, it will come back to its original state. Like you take a scale, rubber scale, plastic scale, you apply a force up to a limit, it will come back. But if you cross that limit, it will break and it will not come back. Before breaking, the condition was this one: stress was directly proportional to strain. After a removal of the stress, the body regains its original shape or size. That is called proportionality relation. So with this, today's class ends. Hope you people have understood. Thank you very much.